Okay, so welcome to our lab for today. So we unfortunately can't be actually doing this lab in class, so we're going to kind of do a virtual lab. So I'm going to walk you through the steps, and you're also going to look at a YouTube video that demonstrates the experiment, and then you're going to work out the questions as you normally would. So we're going to determine the simplest formula of a compound. Okay, and remember that the simplest formula is one that gives us the smallest whole number ratio. So that's basically the empirical formula. And we've been determining this, right? We've been given either grams of the different parts, or we've been given percent composition, and we've been using that to figure out what the empirical formula is. Well, now we're going to be chemists, and we're going to determine in the lab how much of each of the various elements in a compound, what their mass is, and use that to then figure out the empirical formula. Okay, so that's what we're going to do. We're going to determine the mass of given elements and use the mole ratio method, which is what you've been doing, to establish the simplest formula of a compound. Okay, all right. So just a little bit of background on chemistry so you recognize some of the words. So we're going to set up a ring stand. So here's a ring. That one's not too hard to figure out. And here's a clay triangle. So this goes over this ring, and it holds whatever we want sort of above a Bunsen burner flame. Okay, and some other things that we're going to need. This is a crucible. So I think some of you, maybe most of you, have already read the crucible. So here's what a chemistry crucible looks like. It's a ceramic little container with a lid. And as we heat this, right, it's going to get very, very hot, like red hot. So we never want to touch a crucible that could possibly be hot with our hands. So we have crucible tongs. And you notice these little, so there's little part here where you can actually carry the crucible, and the ends you can use to actually pick up the lid using this little piece on the lid. So we never take a crucible in our hands if we have any suspicion that it might be hot. So we use the crucible tongs. Okay, so here's our setup. We're gonna put our triangle and then the crucible. You want to make sure you size these appropriately so that the crucible fits in the ring. And then you want to have this pretty close to the flame, so that inner blue tip should be pretty close here because you want this to be really hot. So we're going to place a crucible and cover on the ring stand, and then we're going to heat it. So we haven't done anything yet. You might be thinking, why are we heating it? Well, ceramics that are just sort of sitting in a room or they've been used before, it may have a little bit of water in there. It may have some other impurities. So we want to burn everything off so that we know we just have the crucible and the crucible cover. Okay, so let's say, we want to make sure it's completely dry. How do we know when it's dry? Well, as it dries, or as we burn off any impurities, the mass of this is going to get lighter. So we're going to keep doing this until we get a constant mass. Okay, so that's what the next couple steps are. You're going to remove it, let it cool, right? Record the combined mass, so put it on a balance with the lid. And then you're going to repeat those steps until you wind up getting a constant mass. So the mass stops decreasing. And at that point, you know you have a completely dry crucible and cover, and you're ready to go with our experiment. Okay? All right. So for our experiment, we're going to burn magnesium. So magnesium you can actually get in these little like ribbons, and we're going to take off about 25 centimeters. It's roughly about 2 inches worth, and put it in the crucible. And then we can determine the combined mass. So you're going to have the crucible, the cover, and the magnesium on the balance. All right, so hopefully now you can figure out what the mass of the magnesium is. You have the mass of the crucible and cover, and the mass of the crucible, cover, and magnesium. So you can figure out the mass of the magnesium that we're starting with. All right, then we're going to start heating this. So here's our setup with our crucible, and you want to leave the cover just a little bit ajar so oxygen can get in, but you want to prevent any smoke or residue from escaping because we want to keep it all in this crucible so that our measurements are more accurate. Okay, so we're going to continue heating this, and eventually the magnesium is going to ignite with a really bright flame. So look at the YouTube video and you'll see this, but notice up above, if you ever do this, do not look directly at the magnesium as it burns. So it's very bright. You just want to give it quick little look-sees, basically, with the lid. Okay, and we keep burning it until basically that reaction stops. All right, and we're going to heat it strongly. Once that reaction stops, make sure everything, the magnesium has fully reacted. And basically what we're doing here is we're reacting the magnesium with oxygen. So that's what happens when you burn things. And here, this is just showing our crucible tongs carrying our crucible. And now we can let that cool. And it should look something like this. So it's kind of ashy. And then the next step, we're going to take a glass stirring rod and carefully grind it up into smaller pieces. So it'll be really fragile at this point. And then some of those pieces will be on the glass stirring rod. So we can rinse those into the crucible with deionized water or distilled water. So we want to make sure that, again, we're not taking any of our product and moving it away from our experiment. We want to keep everything in that crucible. Okay. The other thing we want to do is, while what we want is the magnesium to react with oxygen, since there's a lot of nitrogen in the air, some of the magnesium actually is going to form magnesium nitride. So we want to make sure we get rid of all of that. And so we're going to add some water along with what we've already rinsed into there, just enough to get this magnesium nitride to react with the water. And it's going to then form ammonia gas, magnesium oxide, which is what we want, and heat. So this reaction will get rid of any magnesium nitride. And notice, since ammonia we can smell, we can waft it. Remember wafting from our safety lessons. And then you're going to replace it, put it back on the Bunsen burner, and then you want to boil off the water and dry off the water. And just like we did in the beginning, we want to make sure all of the water is gone and we have a completely dry product. So you're going to do it a few times until you get a constant mass. So you're going to heat it up, let it cool down, measure it, heat it again, let it cool down, measure it until you wind up with the same numbers. Okay? And so now what you're measuring is, think about it, you're going to have your crucible cover, and then your product. So you're going to have magnesium oxide. So that's what your total is. So again, if you go back to your other data, right, we know what the crucible and cover weighs, and now we know what the crucible cover and product weighs, so you can figure out how much product we wound up getting, or how much magnesium oxide. Okay? All right, and then here is some sample data. So you should recognize what we've been doing. So here are the masses, all right, and then the two blue rows are ones you can fill out. And you should see a data table just like this on your lab document. So you'll want to fill in these numbers and then calculate these so that you can continue on and answer the rest of the questions. Okay? So I hope you have an idea of what your experiment looked like. And I'm sorry we can't do it. Though if you're clumsy like me, maybe you're glad you don't have to worry about losing or dropping something. I don't know. But anyway, take a look at the YouTube video and you'll see, maybe get a better idea of the steps that way. And then go on and try your best to answer all the questions on your lab document. All right, have a good day.